In 6.5, this whole chapter has been on something called similarity and dealing with proportions. Now what we're going to do is talk about proportions in triangles specifically. And the first theorem that we're going to use is called the Side-Splitter Theorem. It's so funny, it'll have your sides busting up. I'm just kidding, it's not that funny, but there you go. The Side-Splitter Theorem says that if you have a line that is parallel to a third side of a triangle, here's the third side, here's the side that is parallel, that this line that cuts through the triangle will split it up proportionally. If I look at this, it's the small piece over this piece equals the small piece over this piece, which basically means that you can do the side of the triangle here is proportional, or is over the small piece is equal to this piece over that piece. Or you can do this over that equals this over that. They're all proportional as long as you're only using the sides. I did put a little side note in here because students sometimes get this confused when we talk about the bottom. The bottom, the ones that are parallel, if I have some piece of information here and some other piece of information there, then do not think that you can just use the Side-Splitter Theorem. Let me explain the difference. Let's say that this was 5 and this was 3 and this was x and this was x plus 2. Do not think that you can just do 5 over x equals 3 over x plus 2. That does not work in this case. Because we're dealing with the bottom of the small triangle compares to the right side of the triangle, 5 over x would be equal to the bottom, x plus 2, over the right side of the full triangle. You would have to add those together. Whereas if you had the sides, if I'm only talking about the sides, I can easily do this over that equals this over that. But if I'm talking about the bottom, you cannot just split it up. You have to add for the full distance. I'm hoping that that makes sense to you. Do not get the Side-Splitter Theorem confused with anything that deals with the parallel sides. Keep that in mind. I just wanted you to know that. Let me erase this stuff because I don't want it to get confused for anybody else who looks at this. The second thing, the corollary to the Side-Splitter Theorem says if 3 lines are parallel and 2 transversals intersect them, then the segments are intercepted proportionally. So this is kind of like part of a triangle. We have these lines that are parallel, then the proportions are going to be the same. This over that equals this over that. And because proportions are equivalent to each other, you could even do the left side over right side equals left side over right side. It works. It's very convenient to solve a bunch of problems. The third idea that you'll be using is something called the triangle angle bisector theorem. It talks about if you have an angle bisector, and you know it's an angle bisector because these two angles are congruent to each other, it's going to split this triangle into 2 proportional pieces. 2 triangles that are proportional to each other. What does that look like? That looks like bottom over the bottom is equal to the left side over the right side, or left side over the bottom equals the right side over the bottom. You could set it up almost any single way because they're proportional to each other. We'll do a bunch of problems like that. Keep in mind, all 3 of these rules deal with proportional sides. If a full distances are used, arrows are on a side length, then use subtraction to get the correct side lengths. This is how they're going to try to trick you, and that will be shown to you in my first example in number 10. I have 1, 2, 3 examples picked out for you. You can do these with me if you would like. They're in your book. They are number 10. In number 10, it says, what is the value of x in each figure? I have parallel line, a parallel line. I have a side to side, another side, and a full length. I can use the side-splitter theorem. Except they're trying to trick me on this because they gave me a full distance. They told me what the full length was. They're trying to see if I'm going to take the bait and use the 45. Well, I don't want to use the 45. There's an easier way to do that. Let's use subtraction. So if this is 45, the full length, and that's 30, then what does this little piece have to be? If you know it, say it out loud, please.
15.
Thank you. And once you have that, now you can set up the proportion using the side-splitter theorem very easily. If it was me, I would do something like 10 over x, just because it's written that way, is going to be proportional or equal to 30 over 15. The way that will always work is to cross multiply and set them equal to each other. Some people may want to reduce this first. You can if you want to. I'm going to multiply, cross multiply. And the reason I do that is because it will work no matter what problem I have. There's a nice draft in here. So I'm getting that x is equal to 5. Which would be the same answer if you cross multiplied and reduced as well. The next example I have for you is 24. I like 24 because everything has a variable in it. And the math behind it, whenever you see this word in your textbook, algebra, it means, man, they're going to have to do some algebra stuff. They're going to have to do some Unit 1 stuff to solve for this stuff. Makes it a lot harder. You just, if you see that, not harder, just like, hey, there's more math involved. These two angles are congruent. This must be an angle bisector. If this is an angle bisector, then these things are proportional. It's called the angle bisector theorem, triangle angle bisector theorem. So I'm going to set up a proportion. 7x is going to be over 5x, just the way it looks. Left side over bottom equals right side over bottom. You could have easily just did 7x over 10x minus 4 and 5x over 6x. It doesn't matter how you set it up as long as you're going in the same direction. Now this problem, we can cross multiply. 6 times 7 is 42x squared. And then 5x is going to multiply the 10x minus 4. We're going to have to distribute this. And the way that I'm going to solve this is a way that I taught you way back in Chapter 1 or Unit 1. I'm going to subtract 42x squared from both sides. And 42x squared minus 42x squared is 0 this time. 8x squared minus 20x is equal to 0. You were taught a long time ago that the way to solve for something like this, if you have an x squared and there's an extra x involved, the best way to solve it is to factor it and use something called the zero product property. So what I'm going to do is I'm going to leave it equal to 0, and I'm going to factor out a GCF of a 4x from both of these things, which would make 4x times 2x equals 8x squared, and 4x times a negative 5 would equal the negative 20x. Since this times this equals 0, now I can use something called the zero product property, where the first thing either has to be equal to 0 or the second factor has to equal 0. And I'm going to find my two solutions that way. If you've forgotten this is something we learned way back. I want to say it was 1.6. I'm not quite sure. Let me double check real quick. Solving quadratics by factoring. Yeah, no, 1.7. I was so close. That was off the top of my head too, by the way. I'm impressed that I remembered that. In 1.7 notes in case you wanted to go back and look at it up again. 4 times something equals 0. Divide by 4, divide by 4. X is either equal to 0. Add 5, add 5. Divide by 2, divide by 2. X is equal to 2.5. So if I look at this problem, X is either equal to 0 or 2.5. If I plug in 0, would there even be a triangle over there? No. So this does not even make sense. You can eliminate 0 as a possible solution, and your answer is either 5/2 or 2.5. I would accept either one. But it's a great little reminder of something we learned way back in the when, something that's going to be on your final in the future, 3 weeks from now, 2.5 weeks, if you're really counting. Last example, 35. This example, they have tried to confuse you in every way that they can because you're going to have to do multiple things in this problem. You're going to have to combine 2 of the rules that we have talked about on this on the notes of this page. If I look and I'm trying to find X, let me see. Well, I see a triangle here, I see parallel lines, so I could use side splitter if I knew what FC was. This over this equals, I don't know, over 7.2, but I don't know what that FC is. I see angle bisector, but wait, the triangle ends right here. So what I'm going to have to do is I'm going to have to figure out how long FC is first to be able to then set up a proportion to figure out what X is equal to. So what I'd recommend that you would do is I'd use the triangle angle bisector theorem. Let me use this side over this side. The 9 over the 7.2 would be equal to the 6 over, I don't know what to call this, I'll call it FC. If I figure that out, that will allow me then to be able to figure out the other side to figure out what X is equal to. Now I'm going to cross multiply. 6 times 7.2 equals 9 times FC. Divide by 9 on both sides. 9 goes into 7.2.8 times. 6 times 0.8 must be 4.8 for FC. Now that's not X, but what that's going to do is that's going to now give me enough information to use the side-splitter theorem to figure out what X is equal to. So now what I can do is I can actually take X over the 7.8 equals that new 4.8 over 7.2. And you could set this up in a different way if you wanted to. You could do 7.2 over 7.8 as long as you did 4.8 over X. It would be the same thing. So I'm going to multiply 7.8 multiplied by 4.8 and 7.2 times X and divide by 7.2 and divide by 7.2. Definitely going to use a calculator here. 7.8 times 4.8 divided by 7.2 comes out to 5.2 is what I'm getting. So it's a 2-part problem. I'm going to stop your notes right there.